Hello everyone. In this video, I'll discuss the second question in the homework 5. In this problem that we are given little fxy equals 1 over a times y squared times x, and y is greater than or equal to 1, and x is greater than 1 over y and less than y. The first problem is draw the non-zero definition region of little fxy. So first we know that the little fxy that if it's positive, that a is greater than 0, and we can draw the curve that y equals 1 over x, and draw the line that y equals x, and find the region that y is greater than or equal to 1, and x is greater than 1 over y and less than y. And you can see in this shadow area that little fxy is non-zero definited. The second problem is found the A, so that little fxy is a valid joint density function. So we will do two integrals here. Inside is a definite integral from y 1 over y to y, and it's 1 over a times 1 squared and times x dx, and it equals 1 over a times y squared times 2 times log y, and we do another integral that from 1 to the infinity, and this equals 1 over a times 2, and we need to find the e that make it equals 1, so that a equals 2. The third problem is find and draw the marginal density functions little fx and little fy. So we know that little fx equals the indefinite integral that little fxy dy, and if x is is greater than 0 and less than 1, then the little fx equals the integral from 1 over x to the infinity, and 1 over 2 times y squared times x dy, and it equals 1 over x times x over 2, and it equals 1 over 2. And if x is greater than or equal to 1, we modify the lower bound to x, and it equals 1 over 2 times x squared. And for y, it's easier, so we need to calculate a definite integral from 1 over y to y. This is because y is greater than 0. Y is greater than or equal to 1, and it equals log y over y squared. We can get little fx and little fy in the graph, just like this. The fourth problem is to verify that little fx and little fy are valid density functions. So we know if they are valid density functions, then the indefinite integrals equal 1. And for little fx, we will do two integrals since there are two cases. So the first case is that an integral from 0 to 1, that's 1 over 2 dx, and the second one is from 1 to infinity, that's 1 over 2 x squared dx, and it equals 1 over 2 plus 1 over 2, and it equals 1. For little fy, we only need to do one from 1 to the infinity, that's log y over y squared dy, and it equals 1. So both of them are valid density functions.